Hello students, welcome to chemistry class. So today we are going to start a new chapter in the first PUC syllabus, that is chemical bonding. So this chemical bonding chapter is very important for theory as well as for the competitive exams. Let us see what we are going to study in this chapter. So we all well know that the molecules are generally obtained by the combination of two or more than two atoms of same or different elements, right? So molecules are generally to be formed by the combination of two or more than two atoms of same or different elements. For example, let us take oxygen molecule. So this oxygen molecule is to be formed by the combination of two oxygen atoms. So when the two oxygen atoms are combined and it forms oxygen molecule, right? So this is to be called as oxygen atom. Oxygen atom. And this O2 is to be called as oxygen molecule, right? So it is to be called as molecule. So the molecule is to be formed by the combination of two atoms. For example, let us take H2O molecule. So this H2O molecule is to be formed by the combination of two atoms, that is two hydrogen atoms to be combined with the one oxygen atom. So the two hydrogen atoms and combined with the one oxygen atom and it forms water molecule. Water molecule. So the hydrogens to be combined with the oxygen atoms and it forms molecule. So the molecules are to be formed by the combination of either two or more than two atoms of same or different elements. So in this lesson we are going to study about why do atoms combine and what are the different ways in which the atoms can combine and what are the shapes of the different molecules. So let us see, why do atoms combine? For example, let us take two elements, that is atom of A of element A and B of element B. So the energies of these atoms are to be represented as like this, and when the two atoms are to be combined, that is atom of A and atom of B is to be combined, so it forms a molecule, that is A and B, right? Generally the molecules has less energy as compared to the combining atoms, that is atoms of A and B has high energy as compared to the molecules. So molecules are to be formed to attain the stability. Generally atoms are not stable except noble gases. So in the periodic table we have 118 elements, right? In that only noble gases elements are to be exist in the nature in the atomic state, and the rest of the elements are to be exist in the combined form. Why they are to be exist in the combined form? That is, the simple answer is in order to attain the stability. So in order to attain the stability, atoms are to be combined together and it forms molecules. So the obtained molecules has generally less energy as compared to the combining atoms. So the stability is inversely proportional to the energy. Stability is inversely proportional to the energy of the molecule. So greater the energy of the molecule, lesser the stability, or lesser the energy, that will be greater the stability. So why do atoms are combined? the atoms are to be combined in order to attain the more stability. So in order to attain the stability, atoms are to be combined with each other. That is, between the atoms there is a certain force of attraction, right? So the two atoms are to be held by certain force of attraction. So that force of attraction is to be called as chemical bond. So chemical bond is to be defined as the attractive force which holds the various constituents. So that various constituents are either atoms or ions. So these atoms or ions are to be held together by a force of attraction. That force of attraction is generally to be called as chemical bond, right? So between the atoms of A and B there is a certain force of attraction. So that force of attraction is to be called as chemical bond. Chemical bond. Very simple concept. So chemical bond is nothing but it is a force of attraction. That force holds the constituents together in a different chemical species. That is, in the case of oxygen molecules, between the oxygen atoms there is a certain force of attraction, and in the case of water molecules, between the oxygen and hydrogen atoms there is a certain force of attraction. So this force of attraction is to be called as chemical bond. So in the year 1916, Kossel and Lewis independently explained the formation of chemical bond. So that is to be based on the inertness of noble gases. That is to be based on the inertness of noble gases. Noble gases. That is, based on the inertness of the noble gases, this Kossel and Lewis independently explained the formation of chemical bond. So according to this theory, atoms take part in the bond formation. Atoms take part in the bond formation to complete their octet to acquire the electronic configuration of inert gas atoms. That is, let us take an example of the periodic table. That is, in the periodic table, so only the group 18th elements, that group 18th elements are generally to be called as noble gases. So that noble gases only are stable elements. That is, only noble gases elements are to be exist in the nature in the atomic state. Atomic state means in the single form. So the rest of the elements are to be exist in the combined form. That is, the rest of the elements are to be exist in the combined form. Combined form. So why they are to be exist in the combined form? Simple answer, in order to attain this stability. So how it gets attain this stability? That is by sharing or gaining of electrons. That is, the elements acquires the inert gas configuration either by gaining or losing or sharing of electrons. Let us see what is the outermost electronic configuration of the noble gases. So in the helium, so the outermost electronic configuration is Ns2, and for the neon, argon, krypton, xenon and radon, so all these elements having the outermost configuration, that is Ns2 Np6. That is, the outermost orbital, that is valence shell, contains 2 plus 6, that is equal to 8 electrons. So only the noble gases, that is except helium, that is helium has only 2 electrons in the outermost orbital. So that is to be called as doublets configuration, and it is to be called as octet configuration. So it is doublet configuration, and it is to be called as octet configuration. Octet configuration. So except helium, all the noble gases having the 8 electrons in the outermost orbital, and the helium also most stable element because it has completely filled configuration. That is, ns orbital can accommodate only 2 electrons. The 2 electrons are completely filled in the s orbitals. So according to Kossel and Lewis theory, only group 18th elements are generally stable, and the rest of the elements are not stable, and that elements, in order to attain this inert gas configuration, either they loses electrons or gains electrons. So that is Kossel and Lewis theory. And Lewis introduced a simple notation to represent the number of electrons in the atoms. That is, G.N. Lewis, an American chemist, introduced a simple notation. So this simple notation used to represent the valence electrons. That is, valence electrons is nothing but the electrons present in the outermost orbital. So the last orbital containing electrons are generally to be called as valence electrons. So number of valence electrons present in an atom is to be represented by the simple notation that is to be called as Lewis symbol. Let us see how to represent the number of valence electrons in the atoms. So in the formation of molecule, only the outer shell electrons take part in the chemical combination, and they are to be called as valence electrons. For example, let us take first group elements, that is hydrogen. So this hydrogen contains only one electron in the outermost orbital, right? So that electron is to be represented by using a single dot. So the dot indicates the, so this dot indicates the valence electrons. Valence electrons. Like that, let us take one more element in the first group, that is lithium. So this lithium also contains only one electron, right? So that electron is to be represented by writing one single dot. Like that, second group elements contains 2 valence electrons. So the 2 valence electrons are to be represented by writing 2 dots. So the 2 dots indicates the presence of 2 valence electrons. Like that, the 13th group elements, that is boron family. So this boron family has 3 valence electrons, and carbon family has 4 valence electrons, and nitrogen family has 5 valence electrons, and oxygen family has 6 valence electrons, and halogen family has 7 valence electrons, and this noble gases has 8 valence electrons, right? So the presence of valence electrons in the atoms are represented by using the dots. So each dot indicates the presence of one valence electron. So the number of valence electrons present in an atom is introduced in the simple notation that is to be called as Lewis symbols. So in the examination they may ask what are Lewis symbols. So Lewis symbols is a simple notation used to represent the number of valence electrons in the atom. And next, let us see what are the significance of Lewis symbols. See, the number of dots around the symbol represents the number of valence electron. For example, let us take nitrogen. So this nitrogen has 5 dots. So that 5 dots indicates that nitrogen atom contains 5 valence electrons in the outermost orbital, in the outermost shell or orbital, right? And let us take neon. So this neon also contains 6 valence electrons. So the 6 valence electrons are represented by writing the 6 dots around the neon. So that indicates that 6 dots is the 6 valence electrons present in the neon atom. So the number of dots around the symbol represents the number of valence electrons. And the valency of the element is generally either equal to the number of dots in the Lewis symbol or 8 minus number of dots. So very important concept, that is valency of the element. Valency of the element is generally either equal to the number of dots, that is equal to number of dots in the Lewis symbol, or 8 minus number of dots in the Lewis symbol. So what is this 8 minus number of dots? For example, let us take the first group elements, that is hydrogen. So this hydrogen contains only one dot. So that indicates that valence electrons in the hydrogen atom is 1, and valency of hydrogen is also 1, because the valency of the hydrogen atom is equal to the number of dots. And next let us take the element, that is beryllium. So this beryllium is to be present in the second group. So this hydrogen present in the first group, and this beryllium is to be present in the second group. So that beryllium contains 2 valence electrons. So the 2 valence electrons are represented by writing the 2 dots. So valence electrons of the beryllium is 2, right? And the valency of the beryllium is also equal to 2. And next let us take 13th group elements. 13th group elements, that is boron. So this boron has 3 valence electrons. So valence electrons in the 13th group elements is 3, and the valency of the 13th group elements, so especially for the boron, so the valency is equal to 3. And next let us take 14th group elements, that is carbon family. So that carbon has 4 valence electrons, and that 4 valence electrons are represented by writing the 4 dots. So the valency of the carbon is equal to 4. And next let us take the 15th group elements. 15th group elements, that is nitrogen family. So this nitrogen has 5 valence electrons. So the valence electrons of the 15th group elements is 5. That is up to 14th group, that is first group elements, second group element, 13th group element, and 14th group elements, valency is equal to number of dots in Lewis symbol. Right? So greater than 14th group elements, that is 15, 16 and 17th group elements, 15, 16, 17 and 18th group elements, including noble gases. So the valency of these elements are always equal to 8 minus number of valence electrons. 8 minus number of valence electrons, or it is also to be represented as 8 minus number of dots in Lewis symbol. So let us take a nitrogen atom, and the valency is equal to the 8 minus 5. That is 8 minus 5 equal to 3. And like that, the 16th group elements, that is oxygen family. So this oxygen family has 2, 4, 6 valence electrons. So the valence electrons of the oxygen family is 6 and the valency is equal to 8 minus 6, that is equal to 2. And for 17th group elements, that is noble gases, for example let us take fluorine. So this fluorine has 7 valence electrons. So valence electrons is equal to 7. So valency is equal to 8 minus 7, that is equal to 1. And for 18th group elements, that is noble gases, for example let us take neon. So this neon has 8 electrons. So valence electrons is equal to 8. That is 8 minus 8 is equal to 0. So according to Lewis symbol, we can conclude that why these noble gases are more stable. So valency is nothing but the combining capacity of the atoms. So hydrogen has combining capacity 1 and second group elements has combining capacity 2 and 13th group elements has combining capacity 3 and 14th group elements has combining capacity 4. That is, carbon can form 4 bonds with the other elements and boron can form 3 bonds, beryllium can form 2 bonds, hydrogen can form only 1 bond. Like that, the 15th group elements also has valency 3. That is, the combining capacity of the nitrogen family is 3 and the combining capacity of the oxygen family is 2. That is, oxygen can form 2 bonds and fluorine can form 1 bond. That is, the combining capacity of the fluorine atom is 1. Like that, the combining capacity of the noble gases is 0. So that indicates that only noble gases can be exist in the nature in the single state and the rest of the elements are to be exist in the combined form. That is, in the single state they are not stable. In order to attain the stability, that atoms combined with the either same or different atoms and it forms molecules. So the force of attraction that holds the constituent particles together in a chemical species are generally to be called as chemical bond. So these are all the significance of Lewis symbols. So valency is nothing but the combining capacity of the element. So the combining capacity of the element is either equal to the number of dots in the Lewis symbol or 8 minus number of dots in the Lewis symbol. So by using these Lewis symbols, we can calculate the valency of the elements and also we can conclude the what is the valence electrons present in the atoms. And next let us see the facts stated by the Kossel in the relation to the chemical bond. So according to Kossel theory, that is in the periodic table, the highly electronegative halogens. So highly electronegative halogens means the group 17th elements, 17th group elements. They are to be called as halogens. And the highly electropositive alkali metals. So highly electropositive alkali metals means first group elements. First group elements. So first group elements are called as alkali metals. Second group elements are to be called as alkaline earth metals. And group 13 to 18th group elements are generally to be called as p block elements. And the elements present between the alkaline earth metals, that is s block and p block elements, are generally to be called as transition elements, right? So these transition elements generally has variable valencies or variable oxidation states. So that is why I am not going to calculate the what is the valency for the transition elements, right? So the valency of the elements are to be calculated as either they are equal to the number of dots or 8 minus number of dots. So that concept is applicable only for the S block elements and for the P block elements. So in the periodic table, the highly electronegative halogens and highly electropositive alkali metals are separated by a noble gases. So they are to be called as noble gases. Noble gases, right? So this noble gases separates the highly electronegative, that is halogens. They are to be called as halogens, and the first group elements are generally to be called as alkali metals. Alkali metals. So these halogens and the alkali metals are separated by noble gases. And the formation of negative ion from the halogen atom and the positive ion from the alkali metals are associated with a gain or loss of electron by the respective atoms. For example, let us take any one halogen atom. So the halogen atom, for example Cl atom, that is this Cl gains one electron and it is to be converted into Cl minus. So the presence of one extra electron is to be represented by using the minus sign. So this minus indicates the presence of extra electron. So the Cl gains one electron and it is to be converted into Cl minus. So the electronic configuration for the Cl is neon, and it is 3s2 and it is 3p5. So in the chlorine, it contains 5 plus 2, that is 7 electrons in the outermost orbital. So in order to get the nearest noble gas configuration, it requires 1 electron. So by gaining 1 electron, it is to be converted into, that is neon, and it is 3s2 3p6. So the outermost orbital gets 8 electrons. So in the chlorine atom, it contains only 7 electrons. By the gain of 1 electron, so it gets nearest noble gas configuration, that is the configuration of argon. And let us take a sodium atom, that is sodium contains the configuration, that is neon, and it is 3s1. So neon is 10 plus 1 electron, so total number of electrons present in the sodium is 11. So this sodium loses 1 electron, so it loses 1 electron, it is to be converted into Na plus and plus 1 electron. So by the loss of 1 electron, this Na plus gets the configuration of neon, right? So it gets the configuration of neon because 1 electron present in the 3s orbital is to be eliminated from the sodium. So by the loss of 1 electron, it gets the configuration, that is neon. So it is the nearest noble gas configuration of the neon, right? So both the atoms, that is sodium as well as chlorine, attains the nearest noble gas configuration by the loss or gain of electrons. So this chlorine gains the electrons and the sodium loses electrons, right? Sodium loss of 1 electron gets the nearest noble gas configuration, and the Cl attains the nearest noble gas configuration by the gain of 1 electron, right? So the formation of negative ion from the halogen atom and the positive ion from the alkali metal is associated with the gain or loss of electrons, gain or loss of electrons. And the negative and positive ion acquire a stable noble gas configuration of Ns2Np6, right? So the Cl attains the nearest noble gas configuration, that is outermost noble gas configuration is Ns2Np6. So here also sodium, by the loss of one electron, it gets the noble gas configuration. So the noble gas configuration is 2s2 and it is 2p6. That is the outermost configuration of the neon is Ns2, that is 2s2 2p6. So both the Cl as well as Na plus attains the nearest noble gas configuration either by loss of electrons or gain of electrons. So the negative and positive ions are stabilized by the electrostatic attraction. So what is this electrostatic attraction? That is, when sodium is to be combined with the Cl and it forms a molecule, that is Na plus and Cl minus. So there is a certain force of attraction between the positively charged sodium and negatively charged Cl. So that force of attraction stabilizes this molecule, right? So generally that force of attraction is to be called as chemical bond. So Kossel stated about the chemical bonding, that is in the periodic table, highly electronegative halogens and the highly electropositive alkali metals are separated by the noble gases, and the formation of negative ion from the halogen and the positive ion from the alkali metals are associated with the loss or gain of electrons. And the negative and positive ions acquire a stable noble gas configuration, that is Ns2Np6. That is, this stable noble gas configuration is to be attained by the other than noble gases by the loss or gain of electrons. And the negative and positive ions are generally stabilized by the electrostatic force of attraction. So these are the facts stated by the Kossel in order to the chemical bond. So octet rule is nothing but the atoms can combine either by transfer of valence electrons from one atom to another atom, or by sharing the valence electrons in order to have an octet in their valence shell. So octet is nothing but 8 electrons. So in order to get the 8 electrons in the outermost orbital, either the atoms or losses electrons or gains electrons, or on mutual sharing, it gets the nearest noble gas configuration. That is to be called as octet rule. So very important for 2 marks. So state octet rule. So octet rule states that atoms always combine either by transfer of valence electron from one atom to the another atom, or by sharing the valence electrons, that is on mutual sharing of valence electrons, in order to have the octet in their valence shell. That is, for example, let us take the nucleus and the outermost orbit, that is first shell, second shell, and it is the third shell. So let us take this is the last shell of the atom. So in order to get the 8 electrons in the outermost orbital, 7 and 8. So in order to get the 8 electrons, that is 1, 2, 3, 4, 5, 6, 7, 8. So in order to get the 8 electrons in the outermost orbital, so the atoms are either transfers the valence electrons or sharing of valence electrons in order to have the octet structure. So that is to be called as octet rule. So in the next class we will discuss about what are the types of bonds. That is, there are 6 types of bonds, One is ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond, and van der Waals forces.